Hello! In this video, we'll learn how to find limits precisely using algebra. While graphs and tables give us good estimates, algebraic methods give us exact answers. The first and simplest method is called direct substitution. Let's evaluate the limit of 3x squared minus 5x plus 1 as x approaches 2. For many functions like this polynomial, the limit at a point is simply the function's value at that point, so we can directly substitute 2 for x. We replace every x with 2. Now we follow the order of operations. First, the exponent. 2 squared is 4. Next, we do the multiplications. 3 times 4 is 12, and 5 times 2 is 10. Finally, we add and subtract from left to right. 12 minus 10 is 2, plus 1 is 3. So the limit is exactly 3. Direct substitution works perfectly when the function is continuous at the point. But what happens when direct substitution doesn't work? Let's look at this limit. The limit of x squared minus 1 over x minus 1 as x approaches 1. Let's try substituting 1 for x. In the numerator, 1 squared is 1, so we have 1 minus 1, which is 0. In the denominator, 1 minus 1 is also 0. This result, 0 over 0, is called an indeterminate form. It does not mean the limit is 0, 1, or undefined. It means we don't have enough information yet. We need a new strategy. When we get 0 over 0, it's a clue that the numerator and denominator might share a common factor. Let's revisit our problem. Let's factor the numerator x squared minus 1. This is a special pattern called a difference of squares, which factors into x minus 1 times x plus 1. Now here's the most important concept. The limit is about what happens as x gets very close to 1. But x is never actually equal to 1. Since x is not equal to 1, the term x minus 1 is not equal to 0. And because it's not 0, we are allowed to divide the numerator and denominator by it. This simplifies our expression. Now we have a much simpler limit. We can go back to our first method, direct substitution. We substitute 1 for x, which gives us 1 plus 1. And the final answer is 2, so the limit is 2. Let's try a more complex example. Find the limit of x squared plus x minus 6, all over x plus 3, as x approaches negative 3. First, always try direct substitution. Plugging in negative 3 gives us 0 over 0 again. Time to factor. We need to factor the numerator, x squared plus x minus 6. We are looking for two numbers that multiply to negative 6 and add to positive 1. Let's think. The pairs could be 2 and negative 3, or negative 2 and 3. The pair negative 2 and positive 3 works, since negative 2 times 3 is negative 6, and negative 2 plus 3 is positive 1. So, the factored form is x minus 2 times x plus 3. Since x is approaching negative 3, x is not equal to negative 3. This means x plus 3 is not 0, so we can legally divide by it. This leaves us with the limit of x minus 2. Now we can use direct substitution on this simplified expression. We substitute negative 3 for x. Negative 3 minus 2 gives us our final answer, negative 5. To recap, when finding a limit, always try direct substitution first. If you get a real number, that's your answer. If you get the indeterminate form 0 over 0, try an algebraic technique like factoring to simplify the expression, and then try direct substitution again.